Let's go ahead and restart where we ended last time on example 6, looking for the total area. We have two separate graphs, f of x and g of x. If we looked at both of these graphs, we'll see that f of x is a parabola that has a vertical shift down 4 spaces. And it opens up because the leading coefficient is positive. There's our graph there. What we're looking at over this interval is from here to here, all this area below. So area is from the function to the x-axis. G of x it opens downwards, and it's a vertical shift of 4 spaces up. So I know I have a y-intercept at 4. What are my x? How do I find my x-intercepts? Set it equal to 0. So we have 4 minus x squared. So we have x squared equals 4. Square root both sides. X equals plus or minus 2. Those are my x-intercepts. And if this area, I'm looking at under the graph to the x-axis. That's the area we're looking for. So to find the area, we have to take the integral. The integral finds the area under the curve. We're going from -2 to 2 of both functions. We're doing x squared minus 4 with respect to x. And we're going to find it from -2 to 2 of the other function. Using the properties that we talked about last week, with this function here, we can split it up. So we're looking for the area. We can split these functions up. So we have from -2 to 2 of x squared dx minus the integral from -2 to 2 of 4 dx. Likewise, on this other side, we have from -2 to 2 of 4 minus the integral of x squared dx. So what's the integral of x squared? Whatever the exponent is, which we're going to talk about this also in the next section. We have 2 right now. Since antiderivative is the opposite of derivatives, when we take a derivative, if we take a derivative of x squared, what will we do? We'd bring the 2 down and subtract 1. Now we're doing the opposite. Instead of subtracting, we're adding 1. And whatever your exponent is, divide by it. Since we took the integral of this one, now I can take it from -2 to 2. The integral of 4. The integral of a constant is that constant times x. And we'll talk about that more later this morning. Similarly, we would do the same thing on the other side. So we have integral of 4, which is 4x from -2 to 2. The integral of 2 plus 1 divided by 2 plus 1 from -2 to 2. So the first one becomes x cubed over 3 from -2 to 2 minus 4x from -2 to 2. And the other side becomes 4x from -2 to 2 minus x cubed over 3 from -2 to 2. All I did was work these out. Just x cubed over 3 minus 4x minus x cubed over 3. All right, so we did the integral. Now we have to do this part. This finds the area. So start off with the upper one, and that goes in place of x. So x becomes 2, so 2 cubed over 3 minus -2 cubed over 3. That's this first part. Minus 4 times 2 minus 4 times -2. So we get 8 over 3 -2 cubed is -8 plus, so it makes it a plus 8/3. 4 times 2 is 8 minus 4 times -2, so it makes it a positive. So we got 16 over 3 minus 16 over 1. Get a common denominator, so it's 16 over 3. Multiply this one by 3 over 3. 48 over 3. It makes it -32 over 3. So that's the area of the first one. Why is it negative? Let's do this while you're thinking. Let's do the next one. So here we have 4 times 2 minus 4 times -2 minus 2 cubed over 3 minus -2 cubed over 3. Four times 2 is 8. -4, -2 is a positive 8. So it's 8 over 3 plus 8 over 3, which makes it 16 over 1 minus 16 over 3. Get a common denominator. So it's 48 over 3 minus 16 over 3. Makes it positive 32 over 3. So why are they different signs? One's below the x-axis, one's above the x-axis. That's all it tells you. Because the area up here is positive, down here is negative. Now, to review this, once we take the integral, so the integral of fx, remember, f of x is the derivative of this function. We're trying to find out what was the function before we took a derivative of it, hence antiderivative, before the derivative. Once we find that, then we can find the area by taking the larger minus the smaller. This is the formula we'll be using from here on out for integrals. That's the evolution of it. Which is why when we say find the area of a function, we're talking from the function to the x-axis. That's the area we're looking for. So it's from the function to the x-axis. The area between there. Which is why when we do the steps, it's important to first find the x-intercepts. First find the x-intercepts. I'll show you why. If we had a function sine x on the interval 0 to 2 pi, under the curve, and actually, should not above the curve. It's between the curve and the x-axis. I can't really say above because it's not always above. It could be below. So it's from the area between the curve and the x-axis. That's what we're looking for. So our function is sine x. We're going from 0 to 2 pi. What's the integral of sine? How do we, remember I told you 2 weeks ago, how does the unit circle relate to derivatives and integrals? Since each point is made up of a cosine and a sine, this is the x value, that's the y value. On the top and bottom is sine x, negative sine x, cosine x, negative cosine x. because the points are 0, 1, negative 1, 0, 0, negative 1, 1, 0. The only thing left are the trig functions. Derivatives go that way, integrals go that way. So integrals go counterclockwise. So what's the integral of sine x? Negative cosine x. So it's negative cosine x from 0 to 2 pi. So we take our function, start off with the upper one, which is negative cosine 2 pi, minus the function at the lower, so it's negative cosine at 0. This is f of b minus f of a. So what is cosine of 2 pi? Cosine deals with the x-axis. At 0 degrees, at 2 pi, what's the cosine value here? Cosine is the x value. What's the value there? 1. Cosine's 1. So this one becomes negative 1 because it's a negative in front. Minus, what's the cosine of 0? Cosine of 0 is the same as 2 pi. It's 1, so it's negative 1 again. So we have negative 1 plus 1 equals 0. The area between those are 0. That's an indication that you can't have an area of 0 function unless it's the x-axis itself. The reason it's 0 is because the graph of sine is symmetric. From 0 to 2 pi, we have area above it and we have area below the x-axis, and they're equal. If I added them, what would happen? A plus negative a equals 0. Whenever you have an answer come out to be 0, then we know that it cancels out. So the first step is to find the x-intercepts of the function. So in our function, what are my x-intercepts? So where does sine equal 0? Where? Where does sine value equal 0? You have to know what the sine function looks like. At 0, sine is 0. At pi over 2, the sine is 1. At pi, it's 0. 3 pi over 2, it's negative 1. And at 2 pi, it's 0. So we know that our intercepts are at 0, pi, and 2 pi. The sign is 0 every n pi after that. Because our domain for this function was between 0 and 2 pi, which are the beginning and the end, we have to cut it up into separate pieces. When we do the integral for the area of this, we have to first go in this interval from 0 to pi. And then we have to add the next one from pi to 2 pi. So whatever if you had multiple x-intercepts, you keep on going. But it's always from here to here, from here to here, from here to here, you keep on going. Now we can take the integrals. So the integral of sine is negative cosine, going from 0 to pi, plus negative cosine from pi to 2 pi. It's going to give me the area of those pieces individually. So in this first one, we have negative cosine of pi minus negative cosine at 0. So that's this first one. Plus negative cosine at 2 pi minus negative cosine at pi. That's this one. So what is cosine at pi? Look at it again. Cosine is which axis, x or y? Where, look at your notes. I just wrote it down there a second ago. It's x-axis. So what's the x value at pi? Negative 1. So it's negative of negative 1 minus negative, what's cosine of 0?
Is it still on 1?
Yeah, because it's on the positive side. It's 1, but the negative in front of it, so it's negative 1. Negative. What's cosine of 2 pi? Two pi is the same as 0, because it's all the way around. It's 1. And cosine at pi is negative 1. So we have negative, negative makes it a positive. That makes it a positive. Negative, there's triple negatives. So that one's 2, and this one's negative 2, which is what we expected. One of them is above the x-axis, one of them is below the x-axis. But to find the area, we take the absolute value. So the overall area of this object is 4. Take the absolute value. So finding the x-intercept is very important to keep us in line. So far, so good? All right, we have one more in this section, and then we can move on. Example 8. Find the area of the region between the x-axis and the graph of f of x equals x cubed minus x squared minus 2x on the interval -1 to 2. So far, so good. So step 1. Find the x-intercepts. So we got y equals x cubed minus x squared minus 2x. So the first thing we do, okay, we set it equal to 0, but we got to factor this one out first. They all have an x in common. Excuse me. I factor out an x, we have x squared minus x minus 2. And see if I can go one step further and factor out the other one. So I'm looking for x, that's the middle term. Look at the second sign. Since it's a negative, the signs are opposites. And the bigger number gets the first sign. So what times what is 2? When you subtract them, you get 1. What times what equals 2? When you subtract them, you get 1. So the bigger number gets negative. So 2 goes there, 1 goes there. Remember, set them equal to 0. Now my x-intercepts are, I set each of these equal to 0. So x equals 0, x equals -1, x equals 2. Those are my x-intercepts. Why are those important? Why is knowing those important? What's the graph going to look like? We should know that by now from algebra and pre-calculus. What's the graph going to look like of this function?
Is it going well, is it going like going down and like a hook line?
It's going to be a curve because it's an exponent, right? But what's it going to look like? We know the function, just looking at the equation itself, you can tell me the y-intercept. What's the y-intercept?
0.
0, because there are no constants. When x is 0, y is 0. So that's the y-intercept. We know it's going to have how many vertices? The degree tells us a lot. The degree tells us the maximum number of x-intercepts and the maximum number of vertices. It also tells us the shape of the curve. The leading coefficient. The leading coefficient tells us the direction of the curve. You guys ever heard the term end behavior? Any of your teachers ever tell you that?
No.
Okay. The end behavior of a curve. With this, every function, no matter how you draw it, has to go on to infinity, both directions. What happens to those ends of the graph? Remember, every polynomial, we only look at the leading term. This is the leading term. The leading coefficient, if it's positive or if it's negative, that's the only thing we look at. If n is odd versus n being even, what is n? N is the degree. So if it's positive and odd, no matter how many x-intercepts you have, at the very end, they have to point different directions. Since a is positive, it's an increasing function. As we go to the right, it goes up. If a is negative, that means it's a decreasing function. And everything else, we don't know what happens in there. So that's if n is odd. If n is even and a is positive, both ends point the same direction and they point up. This is an increasing function. If a is negative and n is even, we know this by looking at the first two polynomial functions in algebra. What does this graph look like? It's a parabola. The leading coefficient is what? 1. It's positive, so it opens up. It's even, so they both point up. In this one, it's odd, so they go different directions. And since a is positive, it's an increasing function. We've seen that, we just now have to put it together what we know. So, what do we know about our function? Our function, it's positive, it's an odd function. That means all we know for sure is it has to go opposite directions. On the far left intercept, it goes down. The far right, it goes up. What happens in the middle, we don't know. But we do know because once we factored them out, because all of the multiplicities are odd, we cross the x-axis. If, when you factor them out, if the exponents of these things, if they're odd, then they cross the x-axis. Well, we did that also here. If it's even, it just bounces off the x-axis. If it's odd, it crosses the x-axis. Okay, that's a review from algebra. So when we do our integral, we have to take it between here and here and here and here. We have to do two separate integrals for our function. Oh, no, that's positive. I'm sorry. Oops. I didn't know. I didn't notice this one. My bad. We're going from -1 to 0 to 2. So our graph looks like this. So between -1, because we're going from -1 to 0, that's 2. So from -1 to 0, we're going to do that integral, and then from 0 to 2, do that integral. So our first integral is from -1 to 0 of our function, which was x cubed minus x squared minus 2x dx. And then we have to add it to the next one from 0 to 2. And then whatever they are, we're just simply going to take the absolute value of those and add them together. So what's the integral of x cubed plus x squared plus 2 or minus 2x? Remember what the integral of x cubed is? Whatever the exponent is, add 1. Whatever that is, divide by the same thing. x2 plus 1, 2 plus 1. 2x, this is 1 plus 1. This is 1 plus 1. That goes from 0 to 1. -1 to 0, I mean. Do the same thing for the next one. So it's x3 plus 1 over 3 plus 1 minus x2 plus 1 over 2 plus 1 minus 2x1 plus 1 over 1 plus 1. That's from 0 to 2. So it's x to the 4th over 4 minus x cubed over 3 minus 2x squared over 2 from -1 to 0. And likewise in the other one. So we have x4 over 4, x3 over 3, 2x squared over 2. I mean, you shouldn't have to bobble your head. You should see what there is, and this is basic math. Finish the rest of those. I mean, just by bobbleheading, I'm not getting much warms and fuzzies here. Now what we do, we plug in our bounds. For the first one, in place of x, we do the upper bound, which is 0. So we have 0 to the 4th over 4 minus 0 third over 3 minus the 2's cancel, 0 squared minus -1. So it's -1 to the 4th over 4, -1 cubed over 3 minus -1 squared. That's all in the first box. And we do the same thing with the second box. So we now go from 2 to the 4th over 4, 2 to the 3rd over 3, minus 2 squared, minus 0 over 4, 0 cubed over 3, 0 squared. It's, you don't want to be proud, because if you're having trouble with the basic math, this is the time to do it. Because you don't want to wait till you go to calculus 2 and then fail out of calculus 2 because you don't know algebra. If you don't understand what's going on, this is when you ask questions. So in the first parenthesis, all right, so no questions. In the first bracket, all these are zeros, so that's 0. So we have a minus. Negative 1 to the 4th is 1/4. Negative 1 cubed is a negative 1, so that changes that sign. 1/3. Minus negative 1 squared is -1. Plus 2 to the 4th is 16/4. 2 to the 3rd is 8/3 minus 4. And all of these are zeros. So we have to combine these. Get a common denominator, which is 12. So this is 3, multiply 3/3. This one multiplied by 4/4. And this one is 12/12. Sixteen divided by 4 is 4, minus 8/3 minus 4. Minus 0. The 4's cancel. It should be a minus. So negative in front, so it's 3/12 plus 4/12 minus 12/12 minus negative 8/3. Seven minus 12 is negative 5/12 minus negative 8/3. So it's 5/12 plus 8/3. Get a common denominator. So 5/12 plus 32/12 is 37/12. That's the area under our curve. Basically what it looks like from -1 to 0, it's above the graph, above the x-axis. And then the majority of it is below at 0 to 2. So this one would be 5/12. This is 8/3. When you add them together, you get 37/12. So far, so good. All right, so that's the end of that section.